Welcome everyone and welcome to our sessions on artificial intelligence. So this session is about logistic regression. In the previous sessions we just learned about our first basic machine learning algorithm. So that was a supervised learning algorithm. So why supervised? Because we already know what we need as the output and we are trying to predict that output. So that was a supervised learning algorithm, but under that we have two types of algorithms. One is called as regression and the other one is called as classification. So the machine learning operation that we used was linear regression. So what did we do in that linear regression? So we just saw about what are all the different types of relations that we could get on our data. So if we had x and y, that is nothing but we found out the relationship between x and y and tried to find out how our dependent variable varies with respect to the independent variable. So if my salary, if my age, like if my years of experience is this much, what would be my salary? So similar examples include your data that is nothing but if my marketing spend is this much and if my research spend is so and so rupees, so what would be my profit? So all these things we would be able to calculate. So basically you need to understand the difference between classification and regression. So regressions are used in those problems where you are trying to predict a continuous value. So what is a continuous value? As I told you, if you are trying to predict the future prices or the prices or any quantity or any data continuously, it is not just categorizing the data. If you are measuring past data, previous data and future data, all these continuous data form are like linear regression problems. So that is how you need to find out the data. So that is important for predicting continuous values, but we need to basically understand the whole difference between regression and classification. As the name suggests here, the name is called as logistic regression, but actually this is not a regression algorithm, this is a classification algorithm. So we'll see actually the way we can like classify our algorithm. So we have classification and regression. So in classification we have our linear regression also, but in regression we have linear regression, but in classification we have our logistic regression. So the algorithm that we'll be dealing today is machine learning algorithm, yes for sure, but it is a supervised algorithm and it is a classification algorithm. So our logistic regression comes under this classification algorithm. So there are hundreds of classification algorithms. Our logistic regression is also one. So linear regression, as it states that it is a regression problem where you are trying to find out the future values. So you can see in this particular slide, it is pretty evident to know that if you have some data that is lined up, that is, if you have x and y data, you can predict the future values, the previous values or any value in between. So that is a regression problem that we tried to solve. But the major thing that we'll be trying to solve is the classification problem today. So what is classification? Basically categorizing any data into different parts. So when you have different data, when you want to categorize it into different parts, so you have your data that is nothing but circles and a plus mark. So circles is considered as one part of the data and plus is considered as the other part. So if you want to separate these two, you need to categorize them separately and you need to be able to label them as different quantities or different classes. So that is what is classification. Examples of classifications I can give: email. So when you want to categorize your email as spam email or a regular email, you can use this particular thing, that is for classification. So then you have nothing but whether a person is diabetic or not. Based on upon all the health factors that he has, you can tell the person is diabetic or not on that. Then we have the cancer data, nothing but we can tell whether a person has cancer or not based on the factors of the other quantities being involved. So it may be mathematical or it may be medical quantities that we are trying to use. So any kind of data which we are trying to fit into two parts, either we are telling yes, this person has something, this person has not something, and then if you are trying to tell yes or no, true or false, 0 or 1, anything that you can take in is classification. So classification need not be just two classes. So you can have multiple classes there. What do you mean by multiple classes? It is pretty simple. You have good, better, best. So that it is nothing but you are having three classes. So then you can tell that you are having first class, second class, third class and distinctions in your exam. So you have multiple classes. So classification need not be a single class. It can be two classes. It can be multiple classes. So whenever you're thinking of classification, minimum of two classes must be there, because you need to either classify them as like class 1 or class 2. Minimum two classes must be there. So the algorithm that we'll be dealing is called logistic regression. So logistic regression is a classification algorithm, so which is trying to classify our data into different parts. So this is what we'll be doing today. Now the question comes in, how or why does linear regression cannot be used for our classification problems? So why should we use only logistic regression, and what is logistic regression? And before dealing with what is logistic regression, we'll understand why our linear regression cannot be used as a classification algorithm. So first part is, in any classification algorithm that you take in or any classification data, so one thing you need to understand is all the data will be in the form of zeros and ones. So this is very important. So all the data that you have is in the form of zeros and ones. That is nothing but the end point or a result is in the terms of class of data. Here, how many classes are there? Only two classes. So what are those two classes? Zeros and ones. So 0 meaning that the person does not have any diabetes, 1 meaning that the person has diabetes. So this is how you can categorize your data. So here the data is classified into two parts, nothing but 0 and 1. At the end, what you need to predict, nothing but whether if the person has a is diabetic. So what we'll do is, we'll try to predict 1. So 1 should be the answer. If the person is not diabetic, the answer should be 0. You shouldn't get any middle values like 0.3, 0.7, minus 7.5, minus 1.0, minus 200 or minus 300. That is not allowed. In classification problems, you have only two things to tell, whether the person has diabetes or whether the person does not have diabetes. Only two results should be made available. So if we are trying to plot all these things, so what we can try to do is, here we have our y-axis, which is nothing but whether the person is diabetic or not. So this is a diabetes axis, that is y-axis. Here x-axis is nothing but blood glucose level in mg. So this is our blood glucose level. So if you are starting here from 80, so we all the way we have till 120. So after 120 we have levels reaching up to 180 to 190. So all these levels, you can tell that the data that you have, that is nothing but, the data is nothing but only in two parts. So where is it? It is in 0 and it is in 1. So what are we trying to do here is pretty simple. Either all the data which we map in are either concentrated towards this 0 region or they are concentrated towards 1 region. Why? Because in case of logistic regression or classification problems, the data set is such that, see, you can look at the data set. It is not about the algorithm that you are choosing. So if you look at the data set, you can clearly see that only two types of data are there in the y-axis. It is either a 0 or it is a 1. So what happens if we try to use our classification algorithm is, so this data, when we are trying to predict, or whenever I give a new value or whenever I interpolate it, the problem is there may be chances of my result being greater than 1. So if I try to extrapolate my graph, so if this graph is extrapolated from here, so I have chances of getting results which are greater than 1. So our results will be greater than 1. So that is a major flaw here. So results will become greater than 1. So if my results become greater than 1, so that is a problem for me. Why is it a problem? Because my result should not become greater than 1. My result should be either 0 or 1. And again, the graph can get extrapolated and you can get a result of negative values also. So negative values is also not allowed. So results cannot be negative also. So you will not, results could be less than 1 also. So this is the major problem that we have. So all the data is concentrated here and here. So in order to put a best fit line, so you can't actually draw a best fit line here. Because either you can join 2 points. What points you can join? Either you can join this line and this line. So majority of the points will be missed out. So it is not feasible for classification. Why? The behavior or the way the linear regression is designed in such a way that you can't easily classify the data as 0 and 1. So that is the major problem that you have in this whole point. So in classification algorithms, you need to get only 0 and 1. But in linear regression, the problem is it is nothing but interpolating your graph. So if my blood glucose is at 190 or some level, so if I plot it here, obviously it will be greater than 1, right? So it will be 1.5 or 2. So the main thing is, that is the main issue. So whenever you are trying to do any algorithm, so if it's getting extrapolated and you're getting values greater than 1, that is invalid. Because the only data that we need to get at the end is 0 or 1. So that is very important to understand that linear regression cannot be used for classification. It is good for regression because it can predict any values when I extrapolate my graph. So what is the solution now and how can we solve this whole problem? We'll try to understand. So then we come to the point of what is logistic regression and how this logistic regression is being implemented. So the name logistic regression comes from the log functions or nothing but the logit function, which is nothing but a log function. So what is this logistic function or log function? See, the log function is basically called a sigmoidal function. So terms you need to understand. So we have a sigmoidal function. So what is this sigmoidal function indicating, or how this sigmoidal function is working is pretty simple to understand. You have the expression of nothing but 1 divided by 1 plus e power of minus t. So this is the thing that you have. So 1 by 1 plus e power of minus t. So this is the equation that we have. So if we plot this equation, we don't get a straight line. So what we get instead is nothing but a curved line. So how does this curved line or S-shaped curve look like is pretty simple. So the function when we plot, that is nothing but a sigmoidal function 1 by 1 plus e power minus t. So we'll get a curve that is similar to this. So what is the beauty or what is the importance of this curve is pretty simple. So the maximum value this curve can reach is nothing but 1. So it can't go more than 1. It will be just a constant from 1. So this is very important to understand because it helps our whole thing about classification where you're having data only between 0 and 1. So it can't get extended above 1 or it can't go below 0. So this is what we are getting. So it can't get extended below our value, and it also can't go below 0 and it can't go above 0. So this is the one thing that we are trying to understand. So what is logistic regression is nothing but it is based on the sigmoidal function. So this entire logistic regression is based on sigmoidal function. So what is sigmoidal function? It is of the form 1 by 1 plus e power minus t. So this is telling us what we have to do. So what is the thing that we have? So we have a couple of quantities that nothing but we have our data 120, 90, 120 and 130 which are showing values of 0. So all the values from your 90 to 130. So you can have from 90 to 130 values. So all of them are 0. If it is greater than 130, so greater than 130. So if you have greater than 130, so this is the values that you can have. So very important to understand. So you are having values of only 0 and 1. So the maximum thing that this function can take in is nothing but 1. The minimum thing this function can take is 0. So that is how one problem is solved. So any data that you give in or any value that you want to predict, so that is giving you values of zeros and ones. But what is the thing that is also very eminent is pretty simple to understand. So when you have values such as this, when you have values such as 180, so if you consider your 180, it might be around here. So your 180 value might be around here. So whenever you are trying to get in 180, what is the predictions that you are getting at the end? So when you interpolate it, your prediction is nothing but 1.0. So that is how you are setting a threshold and you are setting a basic thing such that from 90 to 130 you are having data from 0. If after that you are drawing an X-shaped curve stating that after 130 your values are becoming 1. So if it is greater than 130, your values are becoming 1. So that is how this one line is drawn. So more the quantities or more you move towards your 0, the predictions will be, or the estimated quantity will be 0 here. And more away you move from your origin, the values will be 1. So that is very important to understand in this case. What we are trying to do is pretty simple. Whenever we have data, that is nothing but the data of classification works in a totally different way. You can't use a linear regression because linear regression gives you values which are greater than 1 and like 0. So that is not feasible in case of classification where you need to classify your data either as 0 and 1. So that is very important to understand. So what is another important factor is this sigmoidal function will also play a major role. So this advantage of sigmoidal function is nothing but of this form 1 by 1 plus e power minus t, which is telling you that our line is of the form of a sigmoidal function. So sigmoidal function is same as a logistic function. Why? So if you have a data that is nothing but e, so if you take a log of it, so what does it become? So log is always in the form of exponential, so they both are inverse. So if you take exponential of a logarithm, so then it will become the exponential itself. So if you take a logarithm of exponential, so then it will become an exponential. So log and exponentials are two relative terms. So this is also a logistic function or a log function to be precise. So very important to understand. So this is how you can have the data nothing but you have your sigmoidal function, so which is based upon 1 by 1 plus e power minus t. So the advantage of using the sigmoidal function in logistic regression is your values cannot go above 1 and it cannot go below 0. Always the values will be in the region of 0 and 1. So this is very important to understand. So what we are trying to predict in this 0 or 1 is nothing but our probability. So the next factor that you need to consider is what are we doing in this 0 and 1 is nothing but we are trying to print our probability. So what is the probability of me getting diabetes if my value is 90? So if my value is 90, the probability of I am getting like diabetes is around 0. So if my value is around 140 or something, so obviously my probability of getting diabetes is higher. So if it is in 130 or 135 range, so I would have like 0.6 or 0.7% of probability. So that would tell me like whether I have diabetes or not. So that is very important. But the problem is, what if my value is somewhere in the middle? So if I have my values of around like 130 or 134, so if my values is around 134 right around here, so what would be the probability or what would be my chance of getting diabetes or not? So for this reason we have something called as a threshold. So what threshold is doing is, it is setting a base value. So if your value is greater than a threshold, so if you have a threshold of around 0.5 here, so threshold can be set as 0.5. So if my probability is greater than 0.5, so if I am getting a probability of greater than 0.5, so then I am like I have chances of getting diabetic. So if my probability is less than 0.5, then I have less chances of getting diabetes. So very important to understand. So this threshold is also called as decision boundary. So what is this decision boundary or threshold is important to understand. So whenever you have two classes of data, what is the class of data that we have? So this data is called as diabetic data. So this is called as non-diabetic class. So in order to separate your diabetic and non-diabetic class, you need to have a threshold value. So that threshold value is drawn with the help of a line called as a decision boundary. So this decision boundary is separating my two classes, diabetic and non-diabetic. So the threshold is set by default. So you can take the threshold as 0.5. If you want to change the threshold, it is according to your wish. So you can set whatever threshold you want because it is up to the data that you have and the decisions that you can make. So the threshold is a manually set quantity. You can set it as per your requirements. You can set it as a higher value or you can set it as a lower value. So depending upon the threshold, the value that is in the middle. So if you have some values in 135, 130 to 140 range, so it is telling me that I am having doubts regarding the diabetic problem because the probability is not exactly 0 or exactly 1. It comes in the middle, 0.4, 0.7, 0.8 and all those things. So for that you have a decision boundary, that is nothing but a threshold. So you can also call it as a threshold. So if my value or if my probability is greater than the threshold, then I will have, then my chance will go back to diabetes, and if my probability is less, it will become to non-diabetic. But the only thing that we have in classification is, at the end we need to classify the person as non-diabetic or diabetic. So either a 0 or 1. So very important to understand in this thing. So sigmoidal function is very important thing to understand. This entire logistic regression is based on a sigmoidal function. So it is different from your linear regression, because in linear regression you would draw a graph and you need to try to find out the best fit line. So that is how you are able to find all the important quantities. That is nothing but best fit line to give out your result. But here there is no best fit line. But another thing we need to consider here. So if there is no best fit line, so how will we draw the graph? So what we'll try to analyze here is one more thing. So what is the thing that we are trying to analyze is, So this is one particular sigmoidal function that is of the form 1 by 1 plus e power minus t. Okay, fine. So I have drawn the sigmoidal function. So this is having the range of values from 0 to 1. But in the sigmoidal function also we can have many things. For example, if I have data like this, so I can have a data somewhere which can be like this. So the S-shaped curve can change a lot. So this is one type of S-shaped curve. So then you can have a S-shaped curve like a very deep S-shaped curve. So that is also possible here. So these things are also possible. So any different types of S-shaped curve is also possible. Then how do you find which S-shaped curve is good, which S-shaped curve is bad, or which is the best line fit that you can do is very important. In this, we are not calculating the distance between each and every points like we did in linear regression. So how did we find the best fit line in linear regression? It is pretty simple. You calculate the distance between the line drawn and the point surrounding it. Whichever has the least distance, so that is how you could calculate the best fit line. So here, how do you calculate which S curve or which sigmoidal curve or logistic regression curve is the best curve to fit the data that we have between 0 and 1. So what is the data or which is the best thing that we can do is pretty simple. So we have a concept called as maximum likelihood. So what is maximum likelihood is important to understand. So this concept is really helpful in understanding which is the best fit S line. So when you have different S-shaped curves, so which is the best fit S-shaped curve, we'll try to understand using maximum likelihood theorem. So what is maximum likelihood? So before understanding that, we need to consider one more important quantity, that is nothing but odds. So we have a quantity called as odds. So what is this odds telling you is nothing but, it is telling you the probability of an event happening. So divided by the probability of the event not happening. So this is how you define odds. So what is odds is nothing but when you have the probability of event. So what is the probability of event here? I can take it as probability of the person being diabetic. So that can be taken as like the P of E. So then divided by 1 minus P of E is nothing but the probability of event not happening. So it is nothing but happening versus not happening. So that is how you can define your odds. So how do you calculate that which is the best S curve here? So I can tell that this is one best S curve, this is the second best S curve. So you can make all the best curve pass through the points also, yet the angle at which the line or the S-shaped curve is coming out, that may change. So what is important to understand is to get that which is the best curved shaped like the representation of this particular data, you need to understand the maximum likelihood theorem. So what maximum likelihood theorem is telling you is, so you need to calculate the odds of each and every data. So what is the odds of each and every data? So whenever you consider the odds, that is nothing but your probability. So whenever you are trying to fit some data, what is the probability of the data happening and what is the probability of the data not happening? So from this graph, I can tell you that if it is 140 and above or 150, you have probability of odds happening as 100%. So happening is 1 minus, okay, not happening is 0, so that is very important. So probability of happening versus probability of not happening, you will get as see, one thing is, if you change your odds and you try to plot the graph here, so this will change from infinity to minus infinity. So very important to understand. Yeah, you can see here, so whenever I am plotting my odds, so that is nothing but probability of event happening versus probability of event not happening. So when my values is greater than 140 or 150, so probability of happening an event is 1 because it is 1 exactly, 100%. Then 1 minus probability of not happening is nothing but 1 minus the probability of happening is 1. So 1 minus 1 by 0 is nothing but positive infinity. So my value varies from positive infinity, that is nothing but I have my values varying from positive infinity to negative infinity. So that is very important to understand in the case of when I am plotting a logs of my probability. So whenever I am plotting a log of my probability, so there are two things. So my graph will shift from plus infinity to minus infinity, and the event that was happening, so the event that is happening also will be in the form of plus and minus infinity. So how to calculate whether this graph or the curve that is happening in this graph is perfect or which is the best fit curve is pretty simple. So what you need to do is, you need to calculate the odds of each and every event. So calculate So odds of each and every value. So what is the value that we have right now is whenever you have your data in the form of your curve, so your data will be in points here. So we will try to calculate the odds. So what are the odds of that particular data? So how to calculate odds? Probability of event happening, probability of that event not happening. So how is that possible? So whenever you extrapolate your y-axis, you will get the probability of the event happening divided by 1 minus that value, you will get the odds data. So calculate the odds of each and every value is the step 1. Then you need to calculate the log of odds. So whenever you calculate log of odds, okay, log of odds is nothing but each and every data that you have. You need to calculate the odds. So after that you need to calculate the log of odds. So log of odds is telling you that you need to put the logarithm into picture and you need to calculate each and everything. Then sum of all the log of odds. You sum all the log of odds. So that is the third step. So step 1 is this. Step 2 is this, calculate the log of odds. So step 3 will be calculating the sum of all the log of odds. So this is the step 3. So 3 important steps to calculate which is the best curve or how my best curve is appearing. So how to choose between these 3 curves or any number of curves, which is the best curve that is happening is nothing but using these 3 quantities or calculating the maximum likelihood. So the procedure to calculate maximum likelihood or the mathematical procedure is nothing but you need to calculate the odds of that particular event happening. So what is the odds of the event happening? So probability of the event happening divided by 1 minus the probability of the event happening is nothing but probability of happening versus probability of not happening. So that you calculated for each and every value. So whenever you calculate this odds, so your value will not be in the range 0 to 1, it will be in the range of minus infinity to plus infinity. So you are marking all the points here. So then you need to take the log of all the points that you have. So whenever you are taking the log of all the points, so that is giving you the logarithmic value. So after taking that, you need to add all the log of odds. So there will be log of odds of each and every point that you have taken. So you need to add up all those things. So that is how you will get the sum of all of odds. So which do you think is the best then is pretty simple. So you calculate the log of odds, then you will get minus 3, minus 4, minus 5 and minus 7 and you will get minus 2. So these are the values that you get for different values of your curve. So you have different values of curves that you take into consideration. So to tell that which is the best fit among these 3 curves, so you do the simple thing, that is nothing but you take the odds of that event happening or not happening, then you calculate the log of each and every value of the odds, then you sum up all the log of odds. So if you are getting the higher value, so what is the deduction that we have from this is nothing but higher value better the graph. So what is higher value better the graph is nothing but if you are getting the higher values. Here the highest value is minus 2. So if you are getting minus 2, then that is the best value or the best curve that can be fit into the sigmoidal function or that can be used for logistic regression. So very important, higher the value of the sum of log of odds, the better is the line to fit. So that is telling you maximum likelihood. So what is maximum likelihood is the most probable best fit line is called the maximum likelihood. So how will you calculate the maximum likelihood? Odds, log of odds, sum of log of odds, that is how you calculate the maximum likelihood and draw this perfect S-shaped graph that you want in your logistic regression. So once more I am telling you, it is pretty simple. Logistic regression is just based on the function of sigmoidal function. So why logistic? It is called as logit function or log of odds function is also a right name to call it. So why we are doing this is we don't want the values to reach more than 0 and 1. So our entire range of values should be there within 0 and 1. So that is why we are using this equation and we are restricting our values to be in the form of 0 and 1. Your values cannot exceed 0 and 1. Why? Because our data that we have. So in any classification data that you are trying to use. So in any data set if you open, it will be either two things. If the person has diabetes or something, it will be 0, and it will be 1 if it doesn't have, it is 0. So any data for that matter will be in the form of 0 and 1. So if it is multiple classes, it will be 0, 1 and 2. It is nothing but if the person is good, better or best, it will be 0, 1 and 2. That is how different classes of data is being made. So if you want to try out different classes of data, so this is how you see. Basically what you do is you calculate the sigmoidal function for each and every data. Here we have considered only blood glucose. So if you have multiple data, so you will try to draw the sigmoidal graph. So how to draw it? It is nothing but 1 by 1 plus e power minus t. So this is how you draw the graph. So what is this whole part is pretty simple. So you might ask me what is 1 by 1 plus e power minus t. So t is nothing but the equation of straight line. So t is equal to mx plus c again. So it is mx plus c. What is this mx plus c is nothing but the data that you have. So you can plot this x values and you can draw the entire thing. What is the graph that you are getting? So t is in the form of mx plus c. So that is the graph that you want to draw and you want to plot. So after plotting this graph, you will get this S-shaped curve which is ranging between 0 and 1 when you try to plot this entire graph. So you have zeros. So when you have values between 90, 110, 130, you have all zeros here. So if it is greater than 110, so you are getting ones here. So in order to make this graph, you will use this sigmoidal function to draw this S-shaped curve. So where it is varying between 0 and 1. But how will you decide which is the best curve again? So there are multiple curves. So which is the best curve again? So for that you need to calculate the maximum likelihood. So how will you calculate the maximum likelihood? You need to calculate the odd of each and every value. What is odd of each and every value? Probability of that event happening versus the divided by the probability of the event not happening. So that is nothing but P of E divided by 1 minus P of E. So that is how you create the odds. So after calculating the odds, your range will change from plus infinity to minus infinity. You take the logarithm of each and every odds. So then you sum all the log of odds. Whatever sum of log of odds, if you are getting the maximum, so then that is the best graph to consider for plotting this entire thing. So that is the best curve to be considered. So this is about logistic regression mathematical concepts. So this is the mathematics involved in logistic regression. That is how you are obtaining this entire 0 to 1 graph and your values are not varying between 0 to 1 and you are able to predict any data that you give. So if I give in any data, so test data I will give around 190 or 200, so it will be somewhere here. So obviously the probability when I interpolate it is 1, so I have probability of diabetes. So then if I am giving very low values like 60, so the probability is nothing but very low, it is 0. So that is how I need to infer from this data. So it is basically classifying data into two parts, either as class 0 or class 1 with the help of the sigmoidal curve. Sigmoidal curve is helping us do the whole part. And one more thing you need to understand is about the decision boundary or threshold. So you can set a threshold that if the probability of that event happening or if the probability of that person being diabetes is greater than 0.5, so then you can put it on 1.0 and you can place that 1.0 here. You can place that 1.0 around here. So this is how a decision boundary or your threshold is working. So what is threshold? You are manually setting that if my probability is greater than some value, you need to put it in class 1. If it is below that value, you need to put it in class 0. Threshold is very important because we can't predict data as 0.5 or 0.6. So while classification, you can't have intermediate data. Either you should predict as 0 or either you should predict as 1. So this is the entire concept of our logistic regression, and this is how we need to understand our logistic regression. So very important to understand. Now in the next session what we will be doing is we will be trying to solve some logistic regression classification problems using data set. So we will try to implement using scikit-learn and we will try to predict the data. So that is what we will be doing. So thank you guys, and I hope you have understood this.